Today I'm going to be integrating tan to the 6x dx, and there's a couple of ways you can do this. You could do this via integration by parts. I'm not going to be doing quite that today. What we're going to do is start by just writing this integral again. I'm going to write it as tan x to the power of 6, and I'm just going to denote tan x here with t. And what I'm going to do is add on tan to the power of 4x. Okay, but of course I can't just randomly add something on, so I'm going to subtract it off. Okay, cool. Great. So now I've got the integral of tan to the 6x plus tan to the 4x minus tan to the 4x dx. Bit odd, I agree. But let's just play around with this. So I'm going to split this into two integrals. So t to the 6 plus t to the 4 dx, and then minus the integral of t to the 4 dx. And now the trick here is, how am I going to integrate tan to the 6 plus tan to the 4? I'm going to factor out a tan to the 4x. So this is going to be tan to the 4 and then 1 plus, or tan squared x plus 1. So t squared plus 1 dx. And then again, minus this integral of t to the 4 dx. Okay, cool. What is tan squared x plus 1? Well, we can use the trig identity. That's going to be sec squared x. So now if I go back to writing this as tan to the 4x times sec squared x dx, and then I've got minus this integral. I'll just leave that as t to the 4. Now, the great thing about this is we know what this integral here equals. Because the derivative of tan x is sec squared x, we can kind of, if you want to, do a substitution, say u is tan x here, but this is just going to turn out to be 1/5 tan to the 5 of x, like so. And then again, I've got this minus integral of t to the 4 dx. Okay, this is quite cool. I've managed to write the integral of tan to the 6x in terms of what something, and then tan to the 4x. Okay, cool. So now I need to deal with this. Can I do something similar? The answer is yes, we can. So if I do the integral of t to the 4 dx, I'm going to say that's the integral of t to the 4 plus t squared, and then dx, minus the integral of t squared dx, like so. And again, with the first one, we can factor out a t squared. So it's going to be t squared times 1 plus t squared dx minus the integral of t squared dx. Okay, cool. Now this is equal to the integral of tan squared x times 1 plus tan squared x is sec squared x dx, and then minus the integral of tan squared x dx. Cool. This thing here is simply going to be tan cubed x over 3 for the same reason as we had a moment ago. And this thing here, minus tan squared x, well, we can write that as minus 1 plus sec squared x, like so, dx. And this is simply going to become tan cubed x over 3 minus x minus tan x plus c. Great, so that's the integral of tan to the 4x dx. So now we can sub this in over here. This is going to be 1/5 tan to the 5x minus tan cubed x over 3 plus x plus tan of x, and then plus a constant c.